Good morning, students. Today we are going to discuss about random error. Random error, as it is described in the topic, that is a random error. It means to say that, as it is clear from the name, random error means these type of errors in the measurement comes randomly. There is no any influence of the system or the measuring procedure adopted for the experiment, and it occurs randomly, so it is called as random error. Then how the error can occur randomly means whatever the external influences which are not under our control, due to that whatever the error arise in the measurement or the measuring process, that type of errors are considered as random errors. So the errors which occur irregularly, the errors which occurs irregularly and in random in and are random in magnitude and direction. Random in magnitude and direction, that type of error are called as random that type of error are called as random error. Such type of error is called as random error. They arise due to the variation of experimental variation in experimental conditions. Arises due to variations in experimental conditions. Experimental conditions means variation of temperature, pressure, voltage, variation of temperature, pressure, voltage, etc. That is, this type of errors, suppose you are performing Ohm's law experiment, and whatever the supply voltage you are supplying to the apparatus, the voltage is varying at regular intervals or randomly the voltage is varying, that means you have no control over the variation of voltage. Then obviously whatever the resistance or current you are reading due to that setup is going to be varied, and the error must arise due to that variation of voltage. Similarly, the variation of temperature and pressure. So the error which arises randomly, which is not under our control, or due to the variation of experimental conditions, that type of error is called as random error. The another name of this random error is chance error. That is chance error. That type of error which occurs due to chance means all things is okay. You are perfect in doing the experiment, the conditions are okay, the taking observations, the method of taking observations is also good. All things are good, all things are okay, and apart from that, the error coming in the experiment, that type of error is called as random error. This type of errors are called as random errors. Suppose I am taking an example to elaborate the random error. Suppose you are taking the reading by a sensitive balance. The reading is affected on account of vibrations produced in the building due to the vehicles running down the street or by settling of dust particle on the pans. If you are taking the measurement with a physical balance, suppose this is the physical balance, this is the physical balance, and by this physical balance you are taking the observation, and whatever the vibrations occurring in the environment of the physical balance, due to that vibrations the measurement of the physical balance is going to be affected, or whatever the dust particles or anything is going to be attached over the pen, due to that the observation is going to be varied. So this type of the errors which are coming due to these things is called as random error. Now we will discuss on the probability basis. The random errors cannot be eliminated. Random errors cannot be eliminated. Random errors, it is impossible to eliminate random errors. It is impossible to eliminate random. It is impossible to eliminate random errors. But these errors can be reduced by doing repeated these errors can be reduced by doing repeated experiments or taking observations large number of times. Random errors can be understood on the basis of probability by applying Gaussian law of normal distribution. Random errors can be calculated on the basis of Gaussian law of normal distribution. Gaussian law of normal distribution. And what does this law tells? This law tells that if on one of the axis we are drawing the frequency of observation, suppose n number of times we are taking the occurrence, n number of times frequency of occurrence of error, n number of times the error is occurring, then it can be demonstrated by the help of bell-like set. and this is minus delta A, and this is plus delta A. That is probability of occurring plus delta A error is same as minus delta A error. Both the probabilities of positive and negative error in the measurement are same. So this is the Gaussian law of normal distribution to represent random error. Means if the observations are taken n number of times, then what is the probability of occurring of negative error? That is the same. The positive error and negative error we had discussed in the previous video. You must watch that video to understand what is positive error and what is negative error. So that positive error and negative error, the same probability would occur. So by taking the average, we can eliminate this positive and number of observations. By taking large number of observations, we can eliminate this positive and occurrence of positive and negative errors. Now we will discuss it. After that, we will discuss another type of error, and before that, I want to make an statement, note you down, that is accuracy. Accuracy of measurement is related to systematic error. Accuracy of measurement is related to systematic error. It is related to systematic error, but its precision is related to random error. Means by minimizing systematic error, we can improve you can improve the accuracy of the measuring instrument, but by minimizing random error, by eliminating random error, you can get the result which is more precise. So precision is related to random error and accuracy is related to systematic error. The next type of error, that is least count error. Next one is least count error. Least count error. Least count error. Before studying least count error, first of all, you have to understand what is the meaning of least count. Least count means to say that, suppose this is an instrument. Here it is 1, 2, 3, 4 and 5, and there are 10 divisions. There are 10 divisions. 10 divisions. In between two big divisions, there are 10 divisions. So the value of least count means the smallest reading which you can measure. The smallest reading which you measure by this instrument is 1/110, that is 0.1. Suppose it is volt. 0.1 volt. 0.1 volt is the minimum value which can you measure by this instrument. Suppose there is another instrument, there is 1, 2, 3, 4 and 100 divisions are there. 100 divisions are there. 100 divisions in one big division. So the smallest reading which you can measure by the instrument is 0.01 volt. So this is the least count of the given instrument. This is the least count of the given instrument. Suppose 1000 divisions, then 1 upon 1000, 0.01 volt. Similarly for the centimeter scale, meter scale, centimeter scale, ampere scale, whatever the scale you are used to measure the physical quantity, the calibration made over that scale, on the basis of that calibration you can calculate the least count. What is the least count? First of all, write least count. What is the meaning of least count? Least count. The smallest value that can be measured, the smallest value that can be measured by a measuring instrument is called the least count of the measuring instrument. Least count of the measuring instrument, that is called the least count of the measuring instrument, which we had discussed. And I had explained about the least count. So least count error is something which is related to least count. So least count error is the error associated with the resolution of the instrument. Those error which can occur due to closeness of the observation. Means, I want to explain it. Okay, the errors which arises due to the least count of the instrument, due to the least count of the instrument, then how the error arises due to the least count of the instrument? How the error means, this type of error is something related to the precision or resolution of the instrument. This type of error is related to the precision or resolution of the instrument. That is precision or resolution of the instrument. Now I want to explain the least count error. Suppose here there is a meter scale. This is 0, this is 1, this is 2, this is 3. Now there is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 divisions. 1, 2, 3, 4, 5, 1, 1 2 3 4 5 6 7 8 9 10. Now we had placed an object and the object is coming in between this, means this value and this value. Then I am asking that what is the measurement of this object, what is the length of this object. The student A is saying that the object is, suppose this is centimeter scale, so 0.1 2 3 4 5 6. One student is saying that it's 0.6, other student is saying that 0.7. Means there is certain, because the last or terminal point of this body is lying between 0.6 and 0.7. There is no, the terminal point is not coinciding either with 0.6 or 0.7. It is lying between 0.6 and 0.7. Means there is certain error in its 10th place. In its 10th place there is certain error. So this error can be minimized by the help of making the instrument more resolved. So suppose we are taking 100 division, and on taking 100 division the observation is coming at 0.63. 0.63. So the error is coming, this is the exact value and we are getting this value. So the error is coming of 0.03. For this observation the error is coming 0.03, and for this observation the error is coming 0.04. So whatever the difference, the true value minus the measured value, that is the error, and this error is called as least count. This error is called as least count error, which is related to the resolution or precision of the instrument. Means as much precise you will make the instrument, as much resolved you will make the instrument, so much the probability of minimization of error in this case. That is called as the least count error. I think you had understood by this example about the least count error. And this is the least count error. The smallest value which you can measure is called least count, and the error arises due to the least count of the instrument is called as least count error. So least count error can be minimized. This type of error is minimized by adopting more resolved instrument. By taking more resolved instrument, we can minimize this type of error. So we can say that least count error is inversely proportional to the precision of the instrument. From here we can say that least count error is inversely proportional to the precision of the instrument. More precise the instrument, least count error is less precise the instrument, least count error is more. So least count error is inversely proportional to the precision of the instrument. Now absolute error. Now we will discuss about these are the different type of errors. Now quantitatively we will divide the errors. Quanti on qualitative basis we had defined the error. Qualitative basis we had discussed the error in three categories, that is systematic error, random error and list count error. Now quantitatively 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 errors can be classified as, first one is absolute error, second one is mean absolute error, mean absolute error, third one is relative error or percentage error, relative error or percentage error. This error is also called as relative error or percentage error, is also called as fractional error. So first of all we are going to discuss absolute error. Absolute error. Absolute error. Absolute error. Absolute error. Absolute error means to say that error in which magnitude of error is taken in consideration. Magnitude of error is taken in consideration. First of all I want to explain this. After that we will discuss. I will elaborate here. So absolute error, that is denoted by delta A. That is denoted by delta A. And what is the value of delta A? Suppose there is a scale, there is an object, and you had taken the measurement. First measurement you had taken A1, second measurement you had taken A2, third measurement you had taken A3, and the n times you had measured, and at first time you had measured it as A1, second time you had measured as A2, third time you had measured as A3, and the nth time you had measured as AN. Then the true value for this measured, all the measurement what you had made, because each and every time you are getting different values. So what the true value, for the true value you have to find the mean of all the measured value, that is A1 plus A2 plus A3 plus up to so on AN divided by N. This is the true value. And if you are going to subtract the true value, whatever the true value you had got, if you are going to subtract the first measurement from the true value, then there is error in the first measurement, delta A1. Delta A1 is equal to A mean minus A1. Delta A2 is equal to A mean minus A2. Similarly, delta AN is equal to A mean minus AN. This is the error in all the measurements. The absolute error is positive in certain cases and negative in certain cases. Suppose the mean is not, obviously suppose A mean what you had obtained is greater than the measured value A1, then you are obviously you are getting the positive error in the measurement of A1, and in measurement of A3, whatever the mean value you are getting, that is less than whatever the value you had got what in the measurement of A3. So in this case, the error in A3 is negative. So you can get positive and negative error in absolute error. But the magnitude is always positive. Magnitude of the error is always positive. Always positive. So note it down. Absolute error. Absolute error delta A. The magnitude of difference, the magnitude of difference between the true value and the measured value of the quantity is called absolute error. True value and measured value of is called as absolute error, and it is denoted by delta A. This absolute error is denoted by delta A. Suppose measured value be A1, A2, A3 up to shown An. Then true value for the measured values, mean or true value for the measured quantities, and it is equal to, suppose we had that true value we had supposed as Am, that is the mean value, and this mean value is A1 plus A2 plus A3 plus up to shown An divided by n. This is the mean value, and you can write it as A mean is equal to summation I is equal to 1 to n Ai divided by n, in the form of summation. If I is equal to 1, then we are getting A1 plus I is equal to 2, then A2 plus I is equal to 3, then A3 plus up to shown I is equal to n, then An divided by n, and this is called as mean value. I is equal to n to 1 to n. Now error in the first measurement, error in the second measurement, error in the third measurement, del A1, del A2 and del A3. We will discuss numericals, then it is more clear to you while we are discussing numericals regarding that. First of all, try to get the concept. Del A1 is equal to A mean minus A1. Del A2 is equal to A mean minus A2. Del A3 is equal to A mean minus A3 up to soon del AN equal to A mean minus AN. We had subtracted the measured value from the true value and we had got the error in that measurement. True value minus measured value. Error in A2. True value minus measured value. Error in A3. True value minus measured value. Error in AN. Delta AN. Absolute error can be positive or negative, but magnitude of absolute error is always positive. Suppose A1 is less than A mean, then we are getting del A positive, but A2 is greater than A mean, then we are getting, it is not obvious that always you are getting the value of the, always we are getting the measured value which is less than the mean value. When you are taking the mean of various quantities, then suppose you had taken the mean of 1, 3, 4, 5, 6, 7, 8, then whatever the mean value you had got, that mean value is in between 1 to 8, then 7 is greater than the mean value and 2 is less than the mean value, then the difference between the mean value and the measured value might be positive, might be negative. So absolute error might be positive, might be negative, but modulus of the error is always, modulus of absolute error is always positive. Now this is the absolute error. The next discussion is mean absolute error. Mean absolute error. This is the first type of error, that is absolute error. Now mean absolute error. Mean absolute error. Mean absolute error. Mean absolute error. It can be represented as delta A mean. Delta A mean means whatever the errors you had got in the first measurement, that is delta A1, error we had got in the second measurement, that is delta A2, error we had get in the second measurement, third measurement, delta A3, error we had get in the nth measurement, delta AN. Mean of all the errors, mean of all the errors is called as mean absolute error. It is the mean of the magnitudes of absolute errors in all the measurements of the quantity. All the measurements of the quantity, and represented by mean of magnitude of absolute errors. Mean of magnitude of absolute errors in all the measurements of the quantity. Magnitude, you have to take only magnitude, non-sign, either it is positive, negative, does not matter, only we have to take absolute value. So delta A mean is equal to mod del A1 plus mod del A2 plus mod del A3 plus up to son mod del AN divided by n. That is the mean absolute error. Mean of all the absolute errors. And from here we can write it as mean absolute error. Mean absolute error del A mean is equal to summation I is equal to 1 to n mod delta AI divided by n. Obviously, for I is equal to 1 we are getting delta A1, for I is equal to 2 we are getting delta A2, I is equal to 3 delta A3 up to so on I is equal to n delta En divided by n. So if it is the mean value of errors, then if true value which we had obtained is An, then we can write it as plus minus del A mean. Plus minus, in the true value this mean value of error is either added or subtracted. True value is either subtracted. So we can write our result as An plus delta A mean, delta A mean to Am minus delta A mean. Means our measured values can differ from this to this range. Either this much of error is added to the true value and this much error is subtracted from the true value, means our observation is likely to occur between this and this value. Now third one is relative error. Relative error. Relative error. Relative error. Relative error is also called as fractional error, and it is defined as the ratio of mean absolute error upon mean value. It is defined as the ratio of mean value to the mean absolute error. It is defined as the ratio of mean value to mean absolute error. Mean ratio of mean absolute error to the mean value. Mean absolute error to the mean value. So relative error delta A is equal to delta A mean upon A mean. Delta A mean upon A mean. And percentage error is nothing when this relative error is expressed in percentage. When this relative error is expressed in percentage. When this relative error, whatever the relative error we had obtained, when this relative error is expressed in percentage, then how can you express it in percentage? The relative error can be expressed in percentage as percentage error delta A, percentage error delta A is equal to del A mean upon A mean into 100. Whatever the relative error you had obtained, if you are going to multiply with 100, then we can express it as percentage, that much percent. Suppose relative error is coming out to be 0.327, then 100%, then it becomes 32.7%. This is the error. This is the error. So these are on quantitative basis. These are the different classifications, 4 classifications of error, that is mean error, mean absolute error, relative or fractional error, or percentage error. We have discussed this type of errors. While qualitative basis, we have discussed systematic error, then we have discussed random error, then we have discussed least count error. Now in the next video, that is on tomorrow, we will discuss certain numericals, good numericals regarding the error, and after that we will continue with combination of error. That's all students for today. Thank you students, take care, have a good day.